Hi, my name is Alex Augarino, and I'm with Team 6. Please welcome my teammates.
My name is Jacob McAllister.
My name is Heriberto Martinez.
My name is Phil Mark.
And my name is Daniela Martinez, and we are Team 6. I would now like to welcome back Jacob with our overview slide.
Thank you, Danielle. Again, my name is Jacob McAllister, and I'll be going over the overview slide with you. Within the slide, we broke up into a few sections. There's going to be the problem where we discuss what is it we're trying to solve. There's going to be the experiment. How are we going to solve it? The data, what did we collect during the experiment? And finally, the conclusion, the answer to the problem that we're trying to solve. And after that, we'll do a Q&A section with Danielle. And I please ask that you hold your questions until the end. And with that, we'll kick on over to Roberta.
Hello. I will be presenting the problem statement hypothesis for our experiment. Have you ever wondered whether double stuffed Oreos actually had twice the amount of stuffing? Well, Team 6 will try to answer that question. Our problem statement asks, do double stuffed Oreos contain twice the amount of stuffing compared to regular Oreos? And as a basis for our experiment, we created this hypothesis. When you measure the stuffing in double stuffed Oreos, there will be approximately twice as much stuffing compared to regular Oreos. And that concludes the problem statement hypothesis for our experiment. Next, I will pass it on to Alex so he can discuss the limitations and variables for our experiment.
Thanks, Heriberto. I'm Alex, and I'm going to go over the limitations and the variables of this experiment. So the number one thing that you want to establish when doing an experiment are your limitations before you even create your hypothesis or anything else. So number one, budget. Are we going to stick to a budget? Oreos are quite budget friendly. We're in college, so we don't have a lot of money, and they're easy to get. Two, we have other classes. So we got to make sure that we are doing an experiment that won't take many hours to complete, so we can focus on our other classes as well. Now for variables. So to make sure that you answer the hypothesis and adhere to the limitations of the experiment, you got to establish a list of variables. So first you have to establish a method, which Jacob will talk about in the next slide, that will reduce the amount of error and make sure that there's consistency when we are measuring our results. There's also a lot of knockoff brand Oreos, so we got to make sure that we are buying the name brand. To make sure that we are getting an accurate skill set or accurate data set and ensuring that we are not getting any errors from the manufacturer, we are going to test multiple Oreos to reduce the chances of us getting outliers. And we are going to make sure that we spend an adequate amount of time to remove the stuffing so that there's none stuck onto the cookie, so we get accurate results. Now I'll pass it off to Jacob.
Thank you, Alex. I'll be going over our collection methods of the stuffing. For example, we came up with 3 different methods in which we can collect the stuffing. First was the scraping method. Next, it was the dissolving method. And then it was the breaking method. And after we collected the stuffing, we had to figure out a way to measure the stuffing. We decided it was either going to be volume, how much space does it take up? And then it was going to be weight, how much does it weigh? After weighing the pros and the cons for a bit, we decided to come to a justification. Our justification was weighing a Venn diagram of time, accuracy, and skill. With these in mind, we decided upon the scraping method as it provided accuracy, but not so much time and not so much skill. We decided to go on the weight measurement due to the nature of how we're doing these experiments. We're all at home right now, so we don't have access to high accuracy, high degree beakers and ways to measure volume. So we decided to go with easily available weight scales. And with that, we'll go into the setup and how we did these experiments with Roberta.
Hello, I'll be presenting the experiment setups and observations for our experiment. Experiment setups are really important because they can affect the integrity and reliability of the data. Before I start discussing the similarities and differences between our experiment setups, I want you to pause and reflect on how your experiment setup could have affected the integrity and reliability of the data. Here are the similarities between the experiment setups. Each team member used the same product, regular Oreos and double stuffed Oreos. Each team member used paper towels to clean the scale after each measurement. Each team member zeroed out the scale after each measurement. And lastly, each team member used the same scraping method to extract the stuffing from the cookie. And lastly, differences. Each team member had different scales. For example, I had the Nice Well food scale. Next are observations. Here are the observations that the team members made while conducting the experiment. And most of the observations affected the reliability and integrity of the data. For example, no matter how diligent we were when scraping off the stuffing, there was stuffing left on the cookie. The scraped off stuffing had cookie dough residue left on it. The difficulty of removing the stuffing varied by cookie. The weight of the stuffing was not consistent between measurements. The accuracy of the scales varied. And lastly, the data for double stuffed Oreos had more variation than the regular Oreos. However, both of them had variation. As you can see from these two histograms, there's variation in both data sets. However, there's more variation in double stuffed Oreos. We tried to improve the integrity and reliability of the data by keeping the experiment setups as similar as possible. However, our observations had us conclude that the data lacks integrity and reliability. There's too much variation in the data. And thus, the data is not repeatable. And that concludes the experiment setup and observations for our experiment. Next, I'm going to pass it on to Philip so he can talk about the data analysis.
Thank you, Roberto. Your final point references how much variation there was in our data. And aggregating that data, the average weight of the stuffing in a normal Oreo came out to 3.19 grams, while the average double stuffed Oreo weighed in at 5.82 grams. This is fairly close to proving the double stuffed claim that they are in fact actually double stuffed, but it doesn't. Our numbers fall a decent amount short, and with the issues in integrity and reliability of our data, we've determined that while our data doesn't directly confirm the hypothesis that double stuffed Oreos do in fact have double the stuffing, with more trials, the outlier results that we found may be easier to confirm as outliers. And so while our results do not directly support our hypothesis, the results are very close. And with more testing, the team has come to the conclusion that we would be able to prove our hypothesis given more accurate testing. With that, I'm going to pass it on to Daniela for the experiment results.
Thank you, Phil. So my name is Daniela, and I will be going over our experiment results, the manufacturer information, and potential improvements. So as you can see from the data collected from our team, our average for the regular Oreo filling was 3.18 grams, where our average for the double stuffed Oreo filling was 5.82 grams. Now, we took the difference in Oreo filling by subtracting the regular Oreo from the double stuffed Oreo. And with that, we found that the average in difference of Oreo filling was 2.64 grams. Now, does the difference in Oreo filling, is it greater than or equal than the regular Oreo filling? Well, you can see below that some team members found that the answer was yes, while others found that their data showed that it was no. However, on average, we found that the difference in the Oreo filling was 2.64 grams. Therefore, it was not double stuffed. So the answer would be no. Now, you can see from our manufacturer information that the Oreo was 11.27 grams per Oreo. We got that because the total package was 541 grams and there were only 48 Oreos in the package. Whereas in the double stuffed Oreo, there was 566 grams total in the package and only 39 Oreos. Therefore, each Oreo was 14.51 grams. Now, if the two cookies in the Oreo are the same, then if you subtract the Oreo from the double stuffed Oreo, you get 3.24 grams more filling. Now, in comparison, the manufacturer claims there's 3.24 grams more filling. And since Team 6 got that the filling of a regular Oreo is 3.18 grams, then technically it would be double stuffed. However, Team 6 found that there was actually only 2.64 more grams of filling in the double stuffed Oreo. Now, this could be caused by how we measured our data. So some potential improvements are the quality of the scale. As you can see pictured below to the right, one scale only says 3 grams, where another scale would say something a little bit more precise, like 3.12 grams. Now, for future experiments, we suggest an improvement would be getting a quality scale for all team members. However, since we are limited on the scales that we were able to purchase, we had to use the ones that were available to us. So we believe that the data could be more accurate if we had a higher quality scale for each team member. With that, I would like to pass it off to Phil with our conclusion.
Thank you, Daniela. In conclusion, our experiment found that double stuffed Oreos, which claim to be 100% or 200% double stuffed compared to a typical Oreo, this claim does not hold up to scrutiny. However, our results show that the claim is not entirely unfounded, as the numbers fall fairly close to the doubled breaking point that the manufacturer guarantees. And most of the experiment's issues come from the experiment itself, rather than issues with the product itself. While in conclusion, our hypothesis was not supported by our data, the marketing claim does have much more evidence behind it than expected. And even while still technically false compared to our data, the team believes that with further, more advanced testing, that the manufacturer claim could actually be proven correct. With that, I'm going to give it off to Daniela to conduct our Q&A session.
Thank you, Phil. So we'd like to thank you guys for watching our presentation today and encourage you to post any questions that you might have had during the presentation to our discussion board. You can find this by going to ENGR301, go to discussions, and then post on the board for Team 6. Again, we encourage all questions and we'll try to answer them in a timely manner. Thank you again for watching our presentation, and we are Team 6.